In this video, we're going to be talking about the motion of connected particles. Okay, now what are we trying to say? We're going to be talking about how particles behave when they are being connected, usually via a string. Okay, and in different positions and different form and inclinations as well. Okay, I'm going to be starting with something easy, and this is what we call a block and tackle system. Okay, now let's say we're having a mass resting on a platform like this. Let me trace out the platform so you know this is a frame, something like a frame. Okay, I'm going to call this mass M1. Okay, and then M1 is connected via a string, okay, and over a pulley. M1 is connected via a string over a pulley. Okay, here's the pulley. And then it is connected to M2. And then it is connected to M2. Okay? Now, we're asked to calculate the acceleration of this system as well as the tension in the string because it is the same string. So we expect that the same tension will come up in this string. Okay? Now, first of all, let's describe all the things we notice. Now, we'll notice that this one is hanging freely, so we're going to have a weight of W, okay? So I'm going to call the weight W2, okay? Now, notice that this one is on a plane. I'll assume that the plane is rough, okay? So first of all, let's say for a rough plane, okay? So later I'm going to be describing it will be for a rough plane, okay? So we're going to have frictional force, okay? We're going to have frictional force, and then again we're going to have tension in this direction, and we're going to also have tension in this direction. Okay, now this should be in this way. Okay, now it doesn't really matter even if I put the tension in the other direction. I only solve to get a negative sign telling us that it's supposed to be in the other direction. Okay, so if this one is going upward and I solve like this, if I get negative sign, it simply means the tension is also going down. Okay, but of which, using the common sense, we should know that if weight is acting upward and it's hanging from a string, then tension should be in the opposite direction, just so that it balances the weight. Okay, now this is a rough plane, hence there's a frictional force. Okay, first things first, let's find the tension as well as the acceleration. So for tension and acceleration for a body on a plane like this, let's apply the equations of motion. Now W2, which is the weight of M2, is acting downward and tension is acting upward. Now we're going to assume that this body is going to move like this. Okay, we're going to assume that both bodies are going to move in this direction, start coming down. Now why are we assuming like that? We are doing that because we are assuming also that W2 is greater than W1, where W1 is the weight of this body, W1. So if this weight is greater than this one, which is this one is heavier than this one, it will start pulling it downward. Okay, hence let's apply the equation of motion to this first body. Now we'll notice that the weight W2 minus T, that's to get the resultant force. Okay, the resultant force, a vector is acting downward, a vector is acting upward. If this one is to pull this body, it means this one is greater than the one upward. Yeah, okay, for that reason I'm going to subtract the upward one from the smaller one, that's resultant vector, right? So that's W2 minus T, and is equal to the mass times what? Times acceleration. Okay, now what's the acceleration? The acceleration is the acceleration of the whole system. Okay, and this mass will be what mass? The mass of M2. So I'm going to have M2 here. Okay, now W2 in this case is what? M2 times G. Okay, we know W2 is M2 times G, that's mass times gravity, minus tension is equal to M2A. Okay, now we could choose to make tension subjects here. If I make tension subjects, I'll be having tension is equal to M2G minus M2A. Okay, that's what I'm going to have. So I'm going to call this equation 1. Okay, that's what I'm going to do. I'll call that equation 1. And then let's come to this next 610. Okay, this plane is rough, so there's a frictional force, do not forget. Hence, we're going to have T minus the frictional force. Okay, so we're going to have T minus the frictional force equals the mass times the acceleration. Okay, that's the trick. So we're going to have as well T minus frictional force equals mass, which is m1, times the same acceleration. Okay, now in this case we do know that frictional force is mu times the normal reaction. Okay, that's the coefficient of friction times normal reaction. Now for a body that is resting horizontally on a plane, the normal reaction is mass times gravity, which is equal to the weight. So we're going to have R, okay, which is the normal reaction, equals m1a, and then T minus coefficient of friction times mass, which is m1 times g, equals m1a. Okay, so we want to make T subject formula. If I'm making T subjects, we're going to have T is equal to m1a plus coefficient of friction m1g, and I'll call this equation 2. Now we're having two equations, 1 and 2, and T is being equated to both of them. Okay, so if T is equal to this and T is equal to that as well, we can equate both. So we are equating 1 and 2. We're going to get, what's equation 1? m2g minus m2a. So we're having m2g minus m2a, and that equals m1a plus mu times m1g. Now, what we want to do here is make acceleration the subject formula, because we have to find tension and acceleration. So we want to find acceleration first. We're arranging this equation. We can take this to this side. We get m2g minus mu m1g, and that equals m1a plus m2a. Okay, and factorizing that out a from this side, we're going to have m2g minus mu m1g equals a into brackets m1 plus m2. Now we can divide both sides by m1 plus m2. I'm making a subject, so I'm going to write a first. That's a equals m2g minus mu m1g, okay, divided by m1 plus m2. G is common, I can as well factorize it out. So I have acceleration is equal to m2 minus mu m1, okay, multiplied by g, which is the acceleration to gravity, divided by m1 plus m2. Now take note, this is the formula for calculating the acceleration for a system like this. Okay, I'm going to call this case 1. Okay, so for a system like this is the formula for calculating the acceleration. The mass 2, which is the bigger mass, okay, in this case m2 is greater than m1, or w2 is greater than w1, okay, subtracting the coefficient of friction times m1, okay, which is the mass resting on the horizontal plane, multiplying everything by gravity divided by the total mass. That is how it is being solved. So remember, this one I just solved for is for a rough plane. Okay, it is for a rough plane. Now, how about the tension? How do we solve for the tension? Now, for the tension, I'm just going to take this acceleration and put it into any of these formulas. Okay, either I put it in equation 1, and I'll make the subject simplify, or I'll put it in equation 2. Okay, or I could as well bring out a and substitute just the same way I did equation 1 and equation 2, and then I'll solve for T. Okay, I think that will be better. So let's solve for T directly by substituting A into the equation. So from equation 1, I'm going to write from equation 1, okay, from equation 1, I want to make A the subject. So if I should make A the subject, I'm going to have A equals m2g, okay, minus T. This is equation 1. I'm going to have A equals m2g minus T divided by m2, okay, divided by m2. Now this A, I'm going to call it equation 3. Okay, the reason we cannot solve with this is because we do not know tension, so it is as useless as it is on the board. Okay, so I'm going to substitute this equation 3 into equation 2. So substitute equation 3 into equation 2. Okay, and here is equation 2. We're going to have T is equal to m1 times what? A. A is simply m2g minus T over m2. So having m2g minus t divided by m2, okay, that's for a here, plus mu m1g, okay, that's what we're going to get. Now from here we want to simplify and make these subjects, okay. How are we going to do that? Let's first of all expand the bracket. So we're going to have t is equal to m1 m2g, okay, minus m1c divided by m2 plus mu m1g, okay. That's m1 m2g minus m1c over m2 plus mu m1 what now? G. So from here we're going to have t is equal to let's take the LCM denominator to have a common denominator. So we're going to have m2, okay, m1 m2g minus m1c, okay, plus mu m1 m2g. Now what I just did here is a basic math, so this should be easier, not that confusing, okay. Now from here the next thing we're going to do, we're going to cross multiply, okay. After cross multiply we're going to have m2t equals m1 m2g minus m1c plus mu m1 m2g. Now what we want is m1, is t rather, so we're going to collect that and bring this on to this side. That will give us m2t plus m1t equals m1 m2g plus mu m1 m2g as well, okay. Now the next thing we're going to do, factorize that t. So we have t into brackets m1 plus m2 equals m1 m2g plus mu m1 m2g. Making t subjects, we're going to have t is equal to m1 m2g plus mu m1 m2g divided by the total mass, that's m1 plus m2. Now there's a common g outside, okay. G is common, so we can factorize out g as well as m1 m2, but factorizing out doesn't really make it easier, okay. I'll just use to factorize out g only, okay. Or rather m1 and m2, okay. Let's see what we're going to get. So we have t is equal to m1 m2g m1 m2g. We're going to have m1 m2g into brackets 1 plus coefficient of friction divided by m1 plus m2. Now here is the formula for calculating the tension, okay. Now the formula is quite easy. We've simplified up to this point. Now one thing I advise students to do is that if you know you can't memorize this formula, if you know you are not good at memorizing and it will take you time to derive this, it will probably take you time, what you might want to do is learn that of acceleration, and when you've solved for the acceleration you can substitute into equation 1 or equation 2 to get your tension directly, or even without deriving any of these. If you are not asked to bring out the formula for acceleration for any of these, so there should be no need for derivation. In that case, what you are going to do, you are going to substitute with the figures given to you directly and substitute, solve equation 1 and 2, then you get your answer directly, okay, instead of bringing out these formulas. Now I just said these two equations, which I'm going to call equation 4 and I'm going to call this equation 5. These two equations, they are practically useful, okay, when the plane is rough, that is coefficient of friction applies. In that case, coefficient of friction can never be 0, okay. That is when these ones apply. Now how about a smooth surface, okay? For a smooth surface or a smooth plane, okay, for a smooth surface or a smooth plane, these equations are going to change, that of acceleration and that of what now, tension. Now that doesn't mean we're going to start solving again. There's no need of resolving. What we're simply going to do is we're going to note that for a smooth plane, coefficient of friction is equal to 0. So go to these two equations, so we have coefficient of friction and we equate them to 0. So for this case, coefficient of friction here is 0. 0 times m1, you get 0, right? So m2 minus 0, that's 0. So acceleration becomes m2 times g. So you have m2 times g divided by m1 plus m2. Okay, that is when the plane is what now? It's smooth. Okay, and then what about the tension? For the tension, this one is equal to 0. So m1 m2g multiplies 1, you get m1 m2g. So that will give us tension will equal m1 m2g divided by m1 plus what now? Plus m2. Okay, so I think this one is even easier. If they say it is smooth plane, that means coefficient of friction is equal to 0. These ones are easy to learn. Okay, product of mass times g divided by sum of mass, and this one, the bigger weight times g divided by what now? The sum of the masses as well. Okay, so that is how it is being done. This is case 1. Now next video we'll be doing with the next case. Okay, in the next case we could be having an inclined plane, or could be having a pulley in which both masses are hanging over a pulley. Okay, that will be case 2. So if you do enjoy and learn something from this video, do wait to click on the notification bell so that when a new video is being uploaded, you get notified and you'll be among the first persons to learn from these videos. Okay, and as well subscribe to the YouTube channel. The name remains Dr. Flash, and expect more videos from us. Okay, see you in the next video.